In this problem, we have some object placed on a floor, and we have two forces acting on it. One force is pointed directly due east, and another force is pointing at some angle north of west. So if we have some axis here representing the east and west line, then this angle is the 65-degree angle the problem describes. This one is 9.5 newtons, and this one over here is 7.5 newtons. For this problem, we want to find the magnitude of the net force, but since the two forces acting on the object are at different angles and along different axes, the first thing we want to do is find the components and get the net forces along the horizontal and vertical directions. So I'm defining this horizontal axis to be the x-axis, and the vertical axis to be the y-axis, as that tends to be the case. In the horizontal direction, we have the 9.5 newtons directed east, but opposing that, so I'm going to use a subtraction symbol to represent that, opposing that, we're also going to have the horizontal component of this 7.5 newtons. So the horizontal component of this force is going to be 7.5 newtons times the cosine of 65 degrees, using the cosine there because that gets you the horizontal component of the angle. In the vertical direction, we just have the vertical component of the 7.5 newtons directed upwards, so it's going to be positive, so no negative sign like there, and it's going to be 7.5 newtons times the sine of 65 degrees, since the sine is typically used for the y component with angles like this. Now I'm going to plug these into my calculator to get some numerical values for the components. And for the x component, we get about 6.330 newtons. And for the y component, we get about 6.797 newtons. So now we've got some numerical values for the force in the horizontal and vertical direction. So to get the total magnitude of the force, of the net force on the object, we'll use the Pythagorean theorem on these two values to get a net force. So to do that, we just have to take the square root of the sum of the squares of these two numbers. So in these parentheses here, you just put in the numbers that your calculator gave you, 6.33 and 6.797. And what we find is that the net force acting on the object is about 9.2885 newtons, and then of course there are going to be more digits there, but right now I'm just rounding for now. But that gives us the net force on the object. That's not what the problem asks for, however. The problem asks for the magnitude of the acceleration that the object will experience. So for this, we want to bring Newton's second law into it. Newton's second law states that the net force acting on an object is equal to the mass of the object times the acceleration acting on it. And this acceleration is what we want to find. So I'm going to solve for this acceleration by dividing both sides of the equation by m, since the m's cancel out on this side, and we're just left with an a on its own. So we find a formula saying that the acceleration on the object is equal to the net force divided by the mass. Now the problem gives us the mass. We're given the mass directly in the problem as 4 kilograms. And the net force is what we just found by taking the Pythagorean theorem of the two components. So all we got to do is take the value that we just found a minute ago and divide that by the mass. So for this problem, the acceleration of the object is going to be equal to 9.2885 newtons, however many digits you want to include. This is the part where you want to bring in all the digits, as many as you can from your calculators, so that you're preserving as much precision as possible from your earlier calculations. And then you take that and you divide it by the mass, 4.0 kilograms, and we find an acceleration of 2.32213 meters per second squared, which if you want to be accurate to significant figures, you can just round this as 2.3 meters per second squared. And that is the acceleration of the object along the floor. I hope this video helped you out. If there are any questions you have or anything that didn't make sense, you're more than welcome to post a comment in the comment section below, and I'll do my best to help you out. If you have a request for a future video or a problem that you'd like me to do a video on, I have a Discord server also linked below where you all are welcome to join in and ask questions. But that's all for this video, and I hope you have a lovely night. Bye-bye.